Welcome back, learners. So now moving on to our second concept, whereby we'll be looking at the lighting systems that we are using in our homes. So to start, we need to know that electrical energy is supplied to towns, also supplied to cities and every house by the national electricity grid. The electricity supplied to our homes is approximately 220 volts. Remember that this V, it is 4 volts. So therefore, this is going to be 220 volts. Now, that 220 volts is used to power lights, electrical appliances, and anything that we're using at home that uses electricity. Now, in our homes, we are using this type of connection, a parallel connection. Right. The lighting system in our homes are generally connected in parallel, as we have said. The parallel connection have the following advantages. So the reason why we are using a parallel connection in our homes, it is because of the following advantages. That's number one, the light bulbs are each connected to the main circuit in their own parallel circuit. So the light bulbs are connected to their own circuit in their own parallel circuit, to the main circuit in their own parallel circuit. Which then means, because there's more than one pathway for the electric current to follow, if one light bulb in one particular room, it burns out or it gets broken, those other rooms that are still connected to the main circuit will still receive the current, and therefore those light bulbs will light up. So if it happens that one of the light bulbs is broken, or it doesn't work, the other ones can still work because of the more than one pathway or the multiple pathways that are created by the parallel circuit. So now to reiterate, we have said if one light bulb fuses, or that means if its filament breaks, only the one parallel branch is going to be eliminated. The rest of the lights will remain on. So if one light bulb breaks, only that one particular branch is going to be eliminated. However, the other ones will still receive current from the main switch, or rather from the main circuit, and therefore those light bulbs will continue working. And that doesn't mean that if one light bulb breaks, the other one will also break, which is why we are using the parallel circuit in our homes. In addition to that, if more lights are switched on, the voltage across all the light bulbs remain the same, and the brightness of the light bulbs does not change as the light bulbs are switched on and off. Now remember, we are saying this. These light bulbs are used as resistors. Now, if we were to measure a potential difference across each resistor in parallel, it is going to remain the same. It's going to be the same as the total voltage or the total potential difference of the entire circuit, which then means this statement says the voltage across all the light bulbs is going to remain the same. So if we have a 3-room house, the voltage across the light bulb in room number 1 is going to be the same as the voltage in room number 2 and also in room number 3, which then means the brightness of all of those light bulbs will remain the same, because that energy that is needed to push electrons from one point to the other is the same throughout the entire rooms. So that's also one of the main reasons why we are using our parallel circuit when we are connecting the homes and connecting any other appliances that we have at our home. Now, looking at the relationship between the V, the voltage, the I, the current, and R, the resistance. Remember, the symbol for resistance is the omega, and then the symbol for the voltage is your V, and then we know that this is going to be A. The SI unit is going to be A for the current. Now, with this, we are saying in 2 circuits with the same total voltage, the current strength it is going to be larger in the circuit with the lower resistance and smaller in the circuit with the higher resistance. Remember, current and the resistance, they have that relationship that when one increases, the other one is going to be decreasing. So if the voltage remains the same, the current is going to be, it is going to be higher, or is going to be larger if the circuit has a lower resistance. However, the current is going to be smaller if the circuit has a higher resistance. So if the current is larger, it means resistance must be lower. But if the current is lower, that means resistance must be higher. So they will never be the same. Remember, it all depends on the resistance of the circuit. The higher the resistance of the circuit, the lower the current. The lower the resistance of the circuit, the higher the current. Furthermore, For the same total voltage, the current strength through a resistor is therefore inversely proportional to the size of its resistance. So that means the relationship between the current and the resistance is inversely proportional, provided that the voltage remains the same. If the resistance doubles, the current strength is going to be halved. So they have that relationship that when one increases, the other one must decrease proportionally. Hence, we're saying that the relationship between the two is inversely proportional. Furthermore, for the same resistance at the same temperature, the current strength through the resistor increases or decreases proportionally to the voltage across it. If the voltage doubles, the current strength also doubles. So now that means the relationship between the resistance, for the same resistance, the relationship between the current and the voltage is directly proportional. When one increases, the other one also increases at the same ratio. If the voltage doubles, the current strength is also going to be doubled, provided that the resistance of the circuit remains the same. If resistance remains the same, then we are going to be looking at the relationship between the voltage and also the current strength. In this case, they are directly proportional. When one increases, the other one also increases with the same ratio. However, when we are looking now at the relationship between, if the total voltage remains the same, we are going to be looking at the relationship between now our resistance and also our current, that their relationship is inversely proportional. When one goes up, the other one must come down. Now remember, they are going to be increasing or decreasing, in this case, in the same ratio. So now, all of these relationships that you're talking about here, the relationship between the current strength and the resistance, provided that the voltage remains the same, or the relationship between the voltage and the current strength, provided that the resistance at the same temperature is constant, it remains the same. That can be summarized by using the Ohm's law that states that the resistance is equals to V over I. That when the resistance increases, the current must decrease, provided that the voltage remains the same. So if these two have a certain relationship, as we can see, when one goes up, the other one goes down, that means the relationship between the resistance and the current is inversely proportional. One goes up, the other one must come down. Now looking at this relationship here, we are saying for the same resistance, if this remains the same, these two will have a directly proportional relationship, that when one goes up, the other one will also go up with the same ratio. If we double the potential difference, or if we double the voltage, we are also going to be doubling the current, provided that the resistance is going to remain the same in that particular circuit. So with all of that said, learners, I hope you had as much fun as I did learning about the resistance or the potential difference and also the current, the relationship that we have amongst all of these our variables. And we said that we can summarize those relationships by using the Ohm's law, which states that V is equals to IR, and we can manipulate that to R is equals to V over I. And until I see you next time, goodbye.